Hello there! Are you excited for the continuation of our previous lesson? If that's a yes, then prepare your paper and pen as we venture on this new lesson. That is Lesson 3, Part 2, about solving rational inequalities. Are you ready? Let's do this. At the end of the session, you're expected to determine the critical values and solve rational inequalities. Our main topic for this video presentation is solving rational inequalities. Let's review the interval and set notations first. Look at this table. Our answers later for solving rational inequalities will be expressed in these notations. That is why it is essential for us to recall each. Let's start with the interval notation. Let's look at this example. AB with the symbols round bracket, which is your open parentheses, and also your square bracket. A and B here are real numbers like this. You have -2, 5. So our answers at the end of this session are also written in this form. So what do you mean by this? When you see this symbol, which is a rounded bracket, which is for the parentheses, it means that the first number, which is in this case -2, is not included in our solution set. When you see the other one, which is a square bracket like this, it means that the second number, here it's 5, is included or part of our solution. Remember that. So for this, it means that our solution is from -2 to +5. So it's between -2 and 5, excluding -2, but includes +5. Now, for that interval notation, how do we translate that into a set notation? Set notations are like this. Now, focusing on this interval notation, how do we change this into a set notation? It would look like this. Yes. Now, how do we read this one? Enclose in a brace. You'll read this one first as, here it means that the solution would be a set of values. So here it's the set of x. And when you see this vertical line, it's read as such that. So again, that's the set of x such that, then this would be your condition. That your condition here is x will be greater than -2 and less than or equal to +5. There you go. Here, you have the symbol or equal to, since 5 is part of the solution. You can also write it in this form, specifying the type of number. So here, you have the set of values. This time, your values are x, right? X as an element of the real numbers. So here, you read this one as the set of all real numbers x. Again, this one is such that, and this would be your condition. You have there x is greater than -2 and less than or equal to +5. So that would be for your set notation. How about for the graphical form or the graph? It looks like this. Yes, you have it like this. So how about for this one? For the interval notation and the set notation earlier. How do we translate that into a graph? Let's draw a number line first, like this. We will locate the points -2 and 5. Let's start with -2. Since -2 is not part of the solution, we will use an open circle, like this. And since 5, like there, focusing on that point. And 5 is over here. But since 5 is part of the solution, we will now use a shaded circle. And the numbers in between, here, that's represented by the green line segment, is the solution set. Meaning, if your answer will be represented into this format, that means that all the values of x in this line segment, including 5, will satisfy our rational inequality. Again, your solution set would be this, excluding -2, but includes +5, and all the numbers in between. So that's for our brief review. Now this time, let's proceed to our main topic. How do we solve rational inequalities? Given x plus 3 over x minus 2 greater than 0, how do we find the value of x? Do not worry, I'm here to guide you all the way. So follow these steps as your guide. Step 1. Rewrite the given inequality into a single fraction for the left side and a 0 at the right side. So let's check. This is our given, right? On the left side, it is already in a single fraction. On the right side, that's also a 0. Let's check. We are done with step 1. It's already in a single fraction. Do not worry, we still have another example where we can elaborate on the first step. But for now, we'll proceed with our second step. That's step 2. Find the critical values. In rational inequalities, when we say critical values, these are the values that would make the numerator and the denominator equal to 0. So what I'm talking about is like this. Let's look into that. And let's focus on the numerator first. Let's take that out like this. That's x plus 3. We will equate that to 0. And we will find the value of x. So here, we will subtract 3 to both sides to find x, which is -3. And from there, just for you to clearly see, let's substitute that value into our original rational inequality. That's -3, right? Let's substitute like this. It will give us this answer. 0 over -5. 0 divided by any number, like this, which is -5, will always give you a 0. Again, 0 divided by any number will always give you a 0. So here, the answer would be 0 greater than 0. Is this true or false? Is 0 greater than 0? That would be false. Why? 0 is equal to 0 and not greater than or less than 0. Here, if you have this symbol, an additional line right here, which makes it 0 greater than or equal to 0, then that would make this one true. But since there's none, I'll erase that. So that means this is a false statement. And that further means that this is not a solution. What I mean is the value x is equal to -3 right here is not a solution. Let's keep that in mind. Let's take note of that right here. Now, we are done with the numerator. So this time, let's focus on the denominator. Let's take that out. Let's equate that to 0. And let's add 2 to both sides to find x. X will be equal to +2. And let's use that value and substitute that into our given rational inequality. Keep in mind that this value right here would make your denominator 0. So let's check that out. Like this. Let's substitute. So you have this. Performing the indicated operation, you'll have 5 over 0. As mentioned earlier, it will make your denominator 0. Any number divided by 0 will always be undefined. Thus, x is equal to 2 will make this undefined. Therefore, the value 2 for x is still not a solution. Let's take note of that. There we go. So both our critical values, x is equal to -3 and x is equal to 2, are not a solution. We will remember that. And let's place it here. Now, let's proceed to our next step. After finding the critical values, we are going to locate the critical values. How to do that? Let's draw a number line. Like this. And let's locate -3. Since it is not a solution, we'll use, that will be an open circle like this. And let's locate the other critical value, that's +2, right here. Still not a solution, therefore we will use an open circle. Good. Now this would be our number line. with our two critical values. Looking at it, this divides our number line into three intervals. That would be this one, and the center, and we also have to the right. Now, if you're going to translate that into a mathematical expression, you'll have this. Why? Because our values of x right here are less than -3. Since -3 is not included, we will not write or equal to. So again, these set of values for x will be less than -3. Do you follow? Now, can you guess at the center? This is in between -3 and +2. So you're going to write it in this way. Focus at the center. You'll start from the center. X greater than -3. Again, I'm reading from the center. So I'm reading from x to the left and from the x to the right. I'll start from x to the left. So x greater than -3, which means that the values here are greater than -3. At the same time, it is less than +2. This is your +2, and these values are less than +2. That's why you have this format. Do you follow? How about for the last one? Can you guess? Yes, it's from 2 onwards. So that means these values of x are correct. That will be greater than +2. So these are our three intervals. X less than -3. We also have x greater than -3 and less than 2. And our last interval is x greater than 2. Why is it important to have our intervals? We will be using that in our next step. Now let's take that out. And our next step is we will select a test point. We will create a table like this where we see the interval, the test point, where we also have here the numerator x plus 3, denominator x minus 2, and we have the fraction on the left side or the rational expression x plus 3 over x minus 2. Now, when we say test point, it's any point that satisfies the interval. So what I mean by that is, for example, let's focus on the first one. X less than -3. So find a number that is less than -3. Any number will do. You can use -4, -5, so on, like -10, -100, or -1000. It really depends on you. For this example, I will use -10. That will be easier for me every time I substitute that value to the numerator or denominator. But again, you can choose any number that you like as long as it satisfies this condition. How about at the center, between -3 and +2? I'll choose 0. How about for the last interval, x greater than 2? I will use +10. There. So these are my test points, -10, 0, and 10. Now, these test points will be useful for our next step, that is for the table of signs. So let's start with the first interval, with the test point, -10. Here, I will write the signs of the answers. What I mean by that is, I will substitute the test point in the numerator, in the denominator, and in the fraction or the rational expression, and write the signs here. So for example, -10, we have it here as x plus 3, so we'll have x as -10. So we'll have -10 plus 3 will give us a -7. So our answer is negative. No need for you to write the specific answer here. What we are trying to get is only the signs, because that will lead us to our answer later on. Now next, how about -10 minus 2 here in the denominator? Again, that's -10 minus 2. That will give us a negative answer. And for this one, for the last part, the whole rational expression, no need for you to substitute the test point. What you need to do is just to divide the signs of the numerator and the denominator. Negative divided by negative will lead to a positive answer. So that's it. So you have positive for this rational expression. Let's proceed to the next column. That is this interval with our test point 0. So let's substitute 0 to x plus 3. That will give us a positive answer. 0 minus 2 will give us a negative answer. Positive divided by negative, the result is a negative answer. There you go. That's why I have written here a negative answer. So that's it. Let's continue with the last column. X greater than 2. With our test point, positive 10. Here, positive 10, let's substitute that to our numerator. Positive 10 plus 3 will give us a positive answer. Positive 10 minus 2 will give us a positive result. And a positive divided by a positive will lead to a positive answer. So here, what we need to look into is the final answers, the final signs. So our final sign here is a positive. Allow me to annotate. This would be the positive sign. We have here a negative sign, and this will be our positive. So we are going to focus on those signs. Now, for our next step is, we need to look at this. The given inequality symbol. Since we already have here a single fraction and a 0 at the right side, we need to remember our inequality symbol. That means this rational expression is greater than 0. To clarify, it means that these numbers right here, or this rational expression, is equivalent to a set of values that are greater than 0. So what are those values that are greater than 0? Are those positive or negative? Right, those are positive integers. So that means we are going to look into our table of signs with the final sign of a positive sign. So here that will be this. Having a positive sign for the final rational expression. Considering that, again, that will be our answer. So this time, let's write our final answer because we already have identified what interval is for the solution. So how? Let's take out our intervals. And let's go back to our number line. Here, this was for the critical values, right? And we will continue to answer this one through a graph. Since we have x less than negative 3 as part of the solution, that means we are going to shade that part of the number line like this. And the other one, which is x greater than 2, that will be this side, right? So let's have this one, like this. This is already the graph of your answer for this rational inequality. Again, this is only one form. How about converting that into an interval notation? So let's change that. Here, x less than negative 3, right here, will be changed into this form. Now let's understand. Here, it means from negative 3 to negative infinity, which is correct. From negative 3 to all negative integers, going down. And here, you have used a rounded bracket or this closed parentheses, which signifies that negative 3 is not part of the solution, which is correct right here. How about for the other side? How do we translate this into an interval notation? It would look like this. Are you able to get it? Because we have here positive 2, that's from positive 2 to positive infinity. And we are using, again, this open parentheses or the rounded bracket since positive 2 is not part of the solution. Now, since we have two interval notations right here, how do we write our final answer? Unlike the graph, we simply have this form. But for our interval notations, we will include this symbol, which is very important. That would be the union of these two interval notations. So that would be for the interval notation. How about translating this into a set notation? It looks like this. The solution set of the inequality is the set of this. How do you read this one again? This is in our review part. Set of all real numbers x such that x is less than negative 3 or x is greater than 2. Since I'm using union, the equivalent for that is or. That's why I'm using or for the set notation. So this is our answer using the set notation. So we have three. If you have the graph format, the interval notation, and the set notation. You may choose any of these, or it depends on the instruction provided for that problem. So are we good? I hope everything is clear. Well, if not, no worries. You can always go back to the portion of this video for clarification and for mastery purposes. Well, if that's okay now, let's proceed with our second example. How about this? Solve for this rational inequality. Given 2 over x minus 3 is less than or equal to 1 over x. You may pause this video, take your time. I know you can do it. Go ahead. Alright. Now, following the same procedure in example number 1, let's start with step 1. We are going to rewrite the given as a single fraction on the left side and a 0 on the right side. So here, let's check our given. We have a single fraction here, a single rational expression. On the right side, we don't have a 0. What we need to do is to make sure that on the right side, we have a 0 and we have a single fraction on the left side. So what we can do right now is to eliminate 1 over x here to have a 0 on the right side, and later on, we are going to combine that with this given rational expression. So what I'm saying is, let's use subtraction property of inequality like this. Let's subtract 1 over x to both sides, and we will have this. Copy the given, minus 1 over x, then copy less than or equal to, but this time we'll have 0 on the right side. So we have achieved that one already. Now let's look at the left side. Do we have a single fraction here? No, not yet. We have 2 rational expressions, and we are going to combine that to make it a single fraction. So how to do that? Let's find, since they have a different denominator, we are going to find the LCD. That's true. Since both have unique denominators, they don't have a common factor, so both will be part of our LCD. That's the product of x and x minus 3. So from here, what we can do is, we will think of a number or a variable that we can multiply to this rational expression so that its denominator will be the LCD, which is x times x minus 3. We already have x minus 3 here, so that would mean that we will multiply this by x. Do you understand? Again, we will multiply this by x over x so that our new denominator for this part will be the LCD. Same procedure for the second rational expression. We are given here 1 over x. Since we already have x here, so you'll multiply that one by x minus 3. So both the numerator and the denominator will be multiplied by x minus 3. So what I'm saying is, it looks like this. We have here, copying this 2 over x minus 3 over here, and I multiply that one to x over x to make our denominator the LCD. Minus x minus 3 over x minus 3 times 1 over x, which I copied here. And I copy the rest, which is less than or equal to 0. Now let's multiply these, and it will give us this. I'll explain. X times 2 will give you a 2x. I copied minus. And 1 times x minus 3 will give you x minus 3. Enclose that in parentheses since you still have your minus sign. Let's make use of that. And let's distribute the negative sign to all the terms in our binomial. Negative times x and negative times negative 3. Let's look at this. So I copied 2x minus x because that's negative times x. You have negative x here. Negative times negative 3 will give you a positive 3. And I copied the LCD or the denominator and the rest of the inequality. Now, after that, we are going to combine like terms. We have 2x minus x will reveal an x plus 3 because I copied plus 3. So again, it's x plus 3 in the numerator divided by x times the quantity of x minus 3 less than or equal to 0. We are still in step 1, but do not worry because we have here already a single fraction on the left side and a 0 on the right side. So that means we can proceed now to our second step. That is finding our critical values. Again, our critical values are those values that would make the numerator and the denominator 0. Focusing on that, let's take out our numerator first. X plus 3. Equate that to 0. Subtract 3 to both sides. And you'll get x is equal to negative 3. Let's use that value and substitute that in our given rational inequality. It will show this one, which will give us this. A 0 divided by any number will always give you a 0. So this will be 0 less than or equal to 0. Now this time, let's focus on our answer. Is this a true statement? Is this true or false? 0 less than or equal to 0? Because of the or equal to sign, that makes this one a true statement. When I say a true statement, it's true that 0 is less than or equal to 0. So since it's true, that means x is equal to negative 3 is a solution. Let's be reminded of that. Let's put it here. And this time, let's focus on our denominator. Let's take that out. Since our denominator here is written in a factored form, x times the quantity of x minus 3, that means we have two critical values for our denominator. Let's start with x. Equate that to 0, you'll have this. This is our first value for our critical value in the denominator. How about x minus 3? Copy that and equate that to 0. Like this. Here, we can add 3 to both sides. So our value of x will be positive 3. So we have two values, 0 and positive 3. Let's use that value and substitute that in our original inequality. Substituting these values will make our denominator 0. When it's 0, that means it's undefined. Again, when your denominator, any number right here, if I change that to a 0 or to a 3, divided by 0 is undefined. That means these two numbers, 0 and 3, they're not part of the solution. Not a solution. Let's keep this in mind. Let's put it in our solution right here. We already have 3. So we have negative 3, which is the solution. And we have 0 and 3. Both are not part of the solution. So those are our critical values. We have negative 3, 3, and 0. Now for the next step, we are going to locate the critical values. What I'm doing here is I arrange from the least to the greatest value. Because in our number line, that will be useful. So let's start locating negative 3. Here. Since it's part of the solution, we will use, correct, we will be using a shaded circle like this. How about for 0? It's not part of the solution. That's right, we will use an open circle. How about for the last critical value? It's 3. It's not part of the solution, so still it's an open circle. And this is now our number line, wherein our critical values served as dividers. It divides the whole number line into, we have 1, 2, 3, and 4 intervals. So the first interval right here, we have these values of x, which are negative 4, negative 5, and so on until negative infinity. These values are less than negative 3. That's why for the first interval, we write it as this, x less than negative 3. How about for the second interval? The values of x here are negative 2, negative 1, and all numbers in between negative 3 and 0. So these values are greater than negative 3, yes. At the same time, it's less than this value, which is 0. Again, that's greater than negative 3 and less than 0. That's why we have it like this, okay? How about for the third interval? We have here between 0 and 3. So we write it as x or the values of x here is greater than 0, that's right here, we have 0, these values are greater than 0. At the same time, it's less than this value, which is 3. How about for the last interval? These values right here, how do we represent that? That would be, these values are 4, 5, 6, and so on until positive infinity. So these values are greater than positive 3. Do you follow? So these are our intervals which we will use in our table of signs later on. So let's get all of these intervals and use that in our table. Like this. So here we have our test point. We have our numerator, which is x plus 3. Our denominator, which is x times the quantity of x minus 3. We also have here our rational expression, x plus 3 over x times the quantity of x minus 3. Now, let's start with our test point for the first interval. Let's think of any number that is less than negative 3. So for this example, I'll use negative 10. How about for the second interval, between negative 3 and 0? So what I have here is negative 1. For the third interval, between 0 and 3, I'll use positive 1. And for the last interval that's greater than 3, I'll use positive 10. So again, these are our test points. We are done selecting our test point. So our next step here is we are now going to complete our table of signs. So what we have here is, we'll start with the first interval. We have negative 10 as our test point. We will substitute that in the numerator. So we have x plus 3. So here, allow me to annotate. So we have here negative 10 plus 3. Negative 10 plus 3 will give you a negative 7. So that means that line right there will give you a negative sign. So for the next one, it's negative 10 times the quantity of negative 10 minus 3. So it will give you, I'll copy negative 10 times the quantity of negative 10 minus 3 is negative 13. So we have here negative times negative will give you a positive result. To be specific, that is 130. Okay, so we have negative for the first one and we have positive for the second one. So this would be our answer. So allow me to erase now. So let's continue. That will be negative, right? And this will be positive. So again, for the last one right here, so we will simply divide our sign. So we have negative divided by positive. Again, that's negative divided by positive will give you a negative answer. How about for the next column? We have negative 1. Let's substitute that here. Negative 1 plus 3 will give you a positive answer. I'll clarify on this. I'll write it here. So that means you'll have negative 1 times the quantity of negative 1 minus 3. You'll have here negative 1 times the quantity of negative 1 minus 3 is negative 4. So that's why you have here a positive answer, which is positive 4. For this line, you'll have positive for that. So I'll erase. So that will give you a positive answer. So positive right here divided by a positive answer, the result is also positive. Let's proceed to the next column. 1. So we have our test point 1. So 1 plus 3 will give you a positive answer. So here, that's 1 times the quantity of 1 minus 3. 1 minus 3 is a negative answer times positive will give you a negative result like this. So positive divided by negative, the answer there would be negative. I hope you're following. So for the next column, we will now substitute the test point, which is positive 10. So we have 10 plus 3 will give us a positive answer. We have 10 minus 3. I'll start here in parentheses. We have 10 minus 3 will give you positive 7 times positive 10. The result is positive as well. So right here, that's positive. So positive divided by positive, the result there is also a positive answer. So this is our table of signs. Let's go back to our inequality symbol. That's very, very important. So we have here less than or equal to 0. this rational expression is less than or equal to 0. So when you say less than or equal to 0, we are referring to values that are, what do you think? Is it positive or negative? That would be for negative integers. So negative is our answer. Let's look for that in our table, and that would be this first and third interval wherein you have negative answer. So let's convert these intervals into a graph. It would look like this. There you go. So we have here our number line with our critical values earlier with our solution -3. At the same time, since we already identified that this set and this set is also our solution, that's why we have it like this. Do you follow? Now here, take note, what I have written here is less than -3. Since -3 is part of the solution, thus we will change that to x less than or equal to -3. Take note of that. Okay. Now, how do we change this? Again, this answer is already for the graphical form or the graph of our solution set. Now, how do we change this into an interval notation? For this one, we'll use this. We have numbers in between 0 and 3 exclusive of these numbers. That's why we are using the rounded bracket. Now, how about for this one? How do we change that into interval notation? Take note, -3 is included, so we will use, yes, a square bracket like this until -infinity. There you go. So this would be our interval notation. So here's our answer now will be this. Do not forget that you are going to include the union. So we have here the union of this two set of answers. So that's for the interval notation. For our set notation, we are going to write it in this form. We have the solution set of the inequality is the set of real numbers x such that x is less than or equal to -3 or x is greater than 0 and less than 3. So that would be for your set notation. So this is now our answer in 3 formats: the graph, the interval notation, and our set notation. I hope everything is clear. Well, if not, no worries. You can always go back to the portion of this video showing you the step-by-step solution until you've mastered the topic. So just take your time and take it slow. Alright, so let's have the activity time. I prepared here 3 items for your practice. Solve each and find x. You can pause this video. You can also take a screenshot and answer this one on your available time. Take it step by step and take it slow. I know you can do it. Go ahead, you can pause the video. And congratulations! That concludes our session for today. That's Lesson 3, Part 2, about solving rational inequalities. I hope you've learned something meaningful for this session. And congratulations for a job well done. As always, keep it up, senior high school students, and see you in the next lesson.